So we're going to talk about epilepsy today. Epilepsy is an interesting disease for lots and lots of reasons. And one of the problems with it is even just defining what epilepsy is. It's one of those things that someone could say, I don't know how to describe it, but I know it when I see it. Okay, so epilepsy is a disease where the sufferers have recurrent and unprovoked seizures, right? So the recurrent is a big part of it. So a seizure is actually not that uncommon. Um, but what is uncommon is people having them over and over again. So just because you have a seizure doesn't mean you have epilepsy, but everybody with epilepsy has seizures. And what is a seizure? Well, the definitions are generally very unsatisfactory, right? So they involve a sudden and uncontrolled period of abnormal brain activity. Now, it'd be tempting to say, don't all neurological and psychological diseases involve abnormal brain activity, right? But what they're talking about when they talk about a seizure is on a very uh, very crude level, in the sense of this is not a fine something wrong in this little area that maybe does some little changes. This is large portions of the brain undergoing very, very strange patterns of activity. Seizures can involve motor symptoms, um, but not always. They don't have to. And they can involve a loss of consciousness, but again, they don't have to. Um, so, so some conditions, this goes back to what I was talking about at the beginning, can cause seizures, but that does not mean a patient has epilepsy. So commonly, um, any kind of head trauma, brain trauma can cause a seizure, but that does not mean that after the trauma is over that the person will have seizures. Though, to be fair, neurotrauma is a common-ish cause of epilepsy. So there's another one there is fever. So seizures can follow a fever, but again, that does not mean that the subject has epilepsy. So depending on who you talk to, epilepsy, some people say, is the most common neurological disorder. It's definitely in the top five and might affect around about 1% of people. There's a sort of a surprising distribution of epilepsy over an age range. So there's this sort of U-shaped curve with a higher incidence in the young and then again in the elderly. Now, the elderly usually get it post um, stroke, essentially, or some other kind of neurotrauma, while in the young, there are more common direct causes. Now, we're going to talk a lot about the causes of epilepsy, but I just want to look at this pie chart because it gives you an impression of what still a lot of people think is true about the causes of epilepsy, and certainly was the case that 10 years ago everybody thought was the case, right? So what we see is that you've got um, epilepsy as a result of an infection and a fever, uh, cerebrovascular or neurodegenerative seizures. So this will be what's making up these peaks at the back here. Head trauma, cancers, right? So these sort of very explicit damage to the brain um, examples. And then this huge slice of the pie, cryptogenic, meaning we don't know what causes it. Now, you can see here we have this two. This is two out of, I think it's about 500 or so. Um, saying genetic, that has a defined genetic cause. Now, what we're going to learn is this cryptogenic cause is actually not really not genetic, and that probably 3/4 of this graph at least has a direct or strong relation to the genetic components of the sufferers. Okay, so epilepsy is problematic. Like a lot of neurological diseases, we don't know the true cause. And so when we don't know the true cause, we try and create these frameworks to separate the disease up, to try and get a conceptual handle on what's going on, right? So the biggest example of this is the DSM manual about neuropsychological diseases. We've got no idea what causes many of these, but we're trying to say, look, these cases look similar. Maybe we'll call that one disease, and these cases look similar. Maybe we'll call that another disease. And it's much the same in epilepsy, right? That they look for sort of similarities in what the seizure looks like, and they try and say, look, all these people have some kind of disease, and this is still going on. A lot of people put a lot of effort into this, and how useful this framework will be in the long run is up for debate, I believe. But the point is that you need to know these words to talk about epilepsy, because this is what everybody uses to discuss epilepsy, to discuss what one patient is suffering from versus another. So the first big term is seizures being focal or generalized. So a focal seizure is by definition restricted to one hemisphere, and in reality usually to a smaller region of the brain than that. While a generalized seizure occurs across both hemispheres, right? So that's sort of a nice cut and dry. If you see abnormal electrical activity in both hemispheres, you have a generalized seizure, and if it's in one hemisphere or smaller area, it's a focal seizure. Now, when I say um, abnormal electrical activity, what am I talking about, right? And I'm talking about EEG recordings. So this is an EEG recording of a focal seizure. And what we're going to do next is talk about what that image was and what we can tell from looking at it.